Hey, welcome back, Marauders. This is the Mixture Lab. It's my favorite lab, so let's go ahead and get started. So in this lab, we're going to be looking at two different chemicals. One is sodium chloride, which you guys know as table salt. And then another one is sodium bicarbonate. And so this one you guys know as baking soda. And then this one is a mixture. This one contains both sodium chloride and sodium bicarbonate. So both baking soda and table salt. We're going to be reacting these with acetic acid, which you guys know as vinegar. All right, so let's get started. We're having an empty weighing dish right here, so I want you to record the mass of the empty weighing dish. You're going to have to subtract that from the mass that's shown on the balance, so you know the mass of just the sample. We're going to start with sodium chloride. So this is sodium chloride, and I'll put it into our weighing dish. All right, so we got a small sample of sodium chloride there. Remember to subtract the mass of the empty weighing dish. All right, I'm going to take that off, and I'm going to set one of our beakers of acetic acid on here. I want you to record the mass of the acetic acid and the beaker. We don't really need to subtract out the mass of the beaker. We don't really care how much is acetic acid and how much is the beaker. It's not really critical for our calculations in this case. So now I'm going to take my sodium chloride and pour that into my sample of acetic acid. And we'll see that really nothing happens. No reaction takes place. And the total mass here, I'll stir it a little bit, but the total mass here should be exactly the same as the mass of the sodium chloride at the beginning and the mass of the beaker with acetic acid in it. If you just add those two numbers together, it should come out to be the same mass as this. And that's because of the law of conservation of matter. We're just mix those two things together, but no reaction took place, no matter was created or destroyed, so it should still weigh the same as it did at the beginning. All right, let's try that again with our next reactant. So our next reactant is the sodium bicarbonate. So I have a new beaker of acetic acid, and so record the mass of this beaker and this acetic acid. And then we need to get a sample of the sodium bicarbonate. So we've got the weighing dish when it's empty, and we'll add in the sodium bicarbonate. Okay, and so you can again subtract the mass of the empty weighing dish to get the mass of just the sodium bicarbonate that's in this sample. And now I'll put that back on here. We can get the mass of the acetic acid with the beaker, and then I'm going to be slowly adding the sodium bicarbonate to the acetic acid. And you can see something's actually happening this time. It's a little more interesting than when we added the sodium chloride. This time a reaction's taking place. You can see those bubbles. You've probably seen this reaction before. The bubbles are carbon dioxide gas that's being produced. And so this time, we've got to finish letting this react. It takes a little while. If we do it too fast, it'll overflow. We'll stir it to pop some of those bubbles, release the carbon dioxide. And as those bubbles are popping, as the carbon dioxide is being released, we're actually seeing that the mass is actually decreasing. So there, I've added all my sample of sodium bicarbonate. We're stirring it to pop the bubbles. We're releasing the carbon dioxide. And so when we're ready to get the final mass here, the mass is not going to be the same as if you just add together the sodium bicarbonate and the acetic acid with the beaker. Okay, it should actually be a little bit less than that. And it's not because we broke the law of conservation of matter, but it's because a reaction took place, and during that reaction, a gas was produced, and that gas was carbon dioxide, and this is an open container, and the carbon dioxide was able to escape. So you can actually see the mass continuing to go down a little bit as those carbon dioxide bubbles pop, as they rise to the surface. The mass here is getting to be a little bit less and a little bit less. So we'll wait a couple more seconds for these bubbles to pop, and we'll record the mass. And so once we get down here to the final mass, after all those carbon dioxide bubbles have been released, we can use that information to figure out how much carbon dioxide was actually produced. The amount of carbon dioxide produced can be found by looking at the total mass of your reactants, the sodium bicarbonate plus the acetic acid and beaker, and then you can subtract this mass, the mass after all that carbon dioxide has been released, and it should be less, and that's how much carbon dioxide was produced. All right, that looks pretty good. I'm going to take that off. All right, now we're going to do it with the mixture. So here's our mixture. This contains the two reactants we just looked at, sodium bicarbonate and sodium chloride. And our goal in this lab is to figure out how much is sodium bicarbonate and how much is sodium chloride. Is it a 50-50 mix? Is it a 30-70? Is it 99-1? We got to figure out what's the ratio in that mix. Okay, what's the percentage of each one? So there's my mixture. We got the mass of it. And here's a new beaker with acetic acid in it. And so this time when I add it, it's going to produce some carbon dioxide. Not as much as the pure sodium bicarbonate, but more than when we just did the sodium chloride. And so what we're going to do here for the calculations is, once we're done, subtract and figure out how much carbon dioxide is produced. And then we'll compare that to how much carbon dioxide would have been produced if it was just pure sodium bicarbonate, and use that to find the percentages in the mixture. All right, so we've added it all. Now we just need to stir and let it finish reacting. Let these bubbles pop. And so when you're calculating, you want to figure out, you need to do the calculations for the pure sodium bicarbonate first and figure out, if it was pure sodium bicarbonate, how much carbon dioxide does it produce per gram, or what percentage of its mass turns into carbon dioxide. And then you can use that information to figure out how much carbon dioxide, based on how much carbon dioxide was produced in this mixture, you can figure out how much of the mixture was sodium bicarbonate, and then the rest of it must have been sodium chloride. All right, it looks like that's done reacting. Not too many more bubbles are popping there. So you can record that final mass, and then you should have all the information you need to complete the calculations. All right, that's it.